trends in atomic size. Shielding effect is the ability of other electrons, especially inner electrons, to lessen the nuclear attraction on the outer electron. Here we have protons in the nucleus, and all the electrons are attracted to the proton in the nucleus because they have different charge. Electron negatively charged, proton in the nucleus positively charged. So they are being attracted, all electrons and are being attracted to the protons in the nucleus. Now we have electrons at n equal to 1, electrons at n equal to 2, electrons at n equal to 3. Shielding effect is the ability of electrons at the inner shell, n equal to 1 inner shell, n equal to 2 inner shell, n equal to 3 valence shell. So shielding effect is the ability of electrons in the inner shell, electrons at n equal to 1 and n equal to 2. Okay, ability of this electron to lessen the attraction of valence electron. This electron is less attracted to the proton because being shielded by the electrons in the inner shells. Being shielded by the electron, that is shielding effect. Valence electron being shielded by the inner electron from the proton inside the nucleus, that is shielding effect. It occurs between electrons of inner orbital, so our inner orbital n equal to 1 and equal to 2. This n equal to 3 is valence shell. Okay, shielding effect occur between electrons of inner orbitals and the electrons occupying the valence orbital. Some shielding effect also occur between electrons of the same orbital. So this electron repel this electron repel. So this is what we call shielding effect as well. Z versus Z effective. Z is nuclear charge, Z effective is effective nuclear charge. Nuclear charge with symbol Z, when the number of protons increase, we have protons in the nucleus. When the number of protons increase, the nuclear charge increase. Means the number of protons increase, the charge of the proton increase. That's what it means. Okay, proton increase, number of proton increase, the charge of the proton increase, nuclear charge increases. So nucleus electron attraction becomes stronger. When this proton, more and more proton, you have more and more protons, means it is more and more positively charged. Stronger positively charged. More positively charged means nuclear charge increases. So if the nuclear charge increases, this nucleus attraction towards the electrons becomes stronger because it has more and more number of protons, more and more positively charged, so it attracts the electron stronger. The nucleus electron attraction becomes stronger. Z effective is the charge felt by the valence electron due to the shielding effect by other electrons. So this is our protons, these are the protons in the nucleus, and then we have electrons at the inner shell at n equal to 1, we have electrons at n equal to 2, electrons at n equal to 3. Electrons at n equal to 1 and electrons at n equal to 2 are the electrons in the inner shell. Electrons at n equal to 3 are the valence electrons. Z effective is the charge felt by the valence electron. Z effective is the charge felt by the valence electron due to shielding effect. Means this electron is less attracted towards this proton number in the nucleus because of the shielding effect by the inner electrons. When Z effective increases, the nucleus attraction towards electron becomes stronger. Means if the charge felt by the valence electron increase, that means the attraction of the nucleus towards this electron is stronger. So Z effective is the nuclear charge minus the number of inner electrons. Our nuclear charge is proton. So Z effective is proton minus number of inner electron. Our inner electron is all electron except valence electron. That is our inner electrons. Example, Z proton number 11 for sodium, inner electron 10. So Z effective is Z minus inner. So plus 1. This is the charge felt by the valence electron, plus 1. Magnesium, proton number 12, inner electron 10. Z effective, Z minus inner, plus 2. So plus 2 is the charge felt by the valence electron of magnesium, and so on. Factors affecting atomic size: change in effective nuclear charge and change in principal quantum number. These two are the factors that affect the atomic size. How? In nuclear charge, for effective nuclear charge, as the Z effective increase means as the charge felt by the valence electron increase, the positive charge felt by the electron increase. That's why the charge felt by the valence increase, because the positive charge felt by the electron increases. Outer electrons are pulled towards the nucleus, pulled closer to the nucleus. So nucleus electron attraction increases, atom becomes smaller because you attract this proton. The attraction of this proton, the attraction towards the electron, it attracts stronger. When it attracts stronger, so the end, this distance will become closer and closer because it attracts. If this charge is strong, it attracts this electron, and this electron will become closer to the nucleus, so the atom size will become smaller. Second effect is change in principal quantum number. As n increase, we know our n, principal quantum number, our energy level. As n increase, shielding effect also increase. Outer electrons are further from the nucleus. When it's further from the nucleus, electrons are less attracted to the nucleus, and then the atom becomes larger. Trends in atomic size. So this is the figure that shows when the number of n increase, going down the group, number of n increase, so atoms become larger and larger. Across the period, the proton number increase, so the size of atom becomes smaller and smaller. Okay, let's look at the trend. Across a period from left to right, this is across a period from left to right, the proton number increases. If you look at the periodic table, the proton number increases. Here we have proton number 19, 20, 21, 22. Proton number increases, atomic size decreases. Okay, the proton number increases from left to right. Nuclear charge increases. When you have more and more proton, means it becomes more and more positive. Nuclear charge increases. When nuclear charge increases, the effective nuclear charge increases. Means the effective nuclear charge means the charge felt by the valence electron is also increased, because this one is more positive, and this electron felt more attracted because the nuclear charge increases. So effective nuclear charge increases. Nucleus attraction towards valence electron stronger, because more and more proton, more positive. So nucleus attraction towards valence electron becomes stronger. Electrons are pulled closer to the nucleus. That's why atomic radii decrease. The atomic size becomes smaller and smaller because the radius decrease. So across a period from left to right, here from left to right, when the proton number increases, the atomic size decreases. Down a group from top to bottom. Okay, down the group from top to bottom, down the group. If you look at the atomic size, from top to bottom means down the group, the atomic size increases. Okay, atomic size increases. Down the group, the proton number increases. Same, now proton number 1, 3, 11, 19, 37, 55. Proton number increases. The number of shell increase due to the number of electron increases. The number of electron increase because number of proton increase. We know that number of proton is equal to the number of electron. So when the number of n increases, number of shell increases due to the number of electron increases. If you have more and more electron, you need new shell. So that's why number of shell increase due to the number of electron increases. When you have more and more shell, shielding effect increases. When you have more and more shell means you have more and more inner electrons. So that's why shielding effect increases. The distance between valence electron and nucleus become further. When the distance become further, this ability of proton to attract outer electron will decrease because the distance become further. Nucleus attraction towards valence electron weaker, thus atomic radii increase. In transition element, here transition element group 3 to group 12, transition element, the atomic size decreases at first but then remain fairly constant. At first, if you look at the atomic size, decrease at first and then becomes fairly constant. The d electrons fill inner orbitals, so they shield outer electron from the increasing nuclear charge much more effectively. As a result, the outer 4s electrons are not pulled closer because we have d orbitals. The d electron that fill the inner orbital, because d can fill up to 10 electron. D electron fill inner orbital, shield outer electron from increasing nuclear change much more effectively. That's why 4s electron are not pulled closer, just a bit, extremely small. Example, arrange each set in order of increasing atomic size. Explain. So we have 37, 19, 55. These are proton number. Proton number same as electrons, number of electrons. So write the electronic configuration for rubidium, potassium and cesium. Then increasing atomic size. So we have to choose the smallest atomic size first. If you write the electronic configuration, you'll see for potassium n equal to 4, rubidium n equal to 5 up till n equal to 5, for cesium up till n equal to 6. So n equal to 4, this is the smallest n, biggest n. So means when you have smallest n, means you have smallest atomic size. So potassium is smaller than rubidium, smaller than cesium. Potassium, rubidium and cesium are in the same group. Going down the group, the number of shell increases due to the number of electrons increases. The shielding effect also increases because we have more and more n, so more and more inner electrons. The distance between valence electrons and nucleus are further. Nucleus attraction towards valence electron weaker, thus atomic size increases from K to cesium. Arrange each set in order of increasing atomic size and explain. Now, write the electronic configuration. Look at the N values. So magnesium has the smallest N value, so it must be the smallest atomic size. For potassium and calcium, these two has the same number of N, but their number of electrons are different. Both are in period 4, but effective nuclear charge are differ. When they both have different number of electrons, means they have different number of proton. We look at the number of proton. Calcium has more proton than potassium. So when you have more proton number, means more nuclear charge increases, effective nuclear charge increases, the attraction of electron towards the nucleus becomes stronger, thus the atomic size with higher proton number is smaller than the atomic size with smaller proton number. So calcium is smaller than potassium. Magnesium has the smallest atomic size because it has 3 shells, while potassium and calcium have 4 shells. The outer electrons of magnesium experience less shielding effect than potassium and calcium. Thus, the nucleus attraction towards valence electrons of magnesium becomes stronger because it has less shielding effect than potassium and calcium. So magnesium has the smallest atomic size because it has 3 shells, while potassium and calcium has 4 shells. The outer electron of magnesium experience less shielding effect than potassium and calcium. Thus, the nucleus attraction towards valence electrons of magnesium becomes stronger.